Engineers use science and technology to make products and solve problems. Have you ever wondered how they do this? Let's look at an extreme example and see if we can find some clues. The spaceship Apollo 13 was launched on April 11, 1970. It had 3 astronauts on board, and its mission was to land on the moon. Unexpectedly, while in flight and approaching the moon, damaged wire insulation led to a spark that caused an explosion. As a result, the oxygen tank lost a lot of the oxygen needed to keep the astronauts alive. The 3 astronauts were facing a complex problem. They needed to find a way to get safely back to Earth, and fast, before the oxygen ran out. This was not something they could fix quickly. They had to develop a plan. They had to redesign the spacecraft and the mission with the help of NASA engineers at the control center on Earth. So, what did the NASA engineers do to solve this problem? They broke the problem of getting safely back to Earth into many smaller, more manageable problems and got to work. The astronauts took residence in the lunar module to save fuel. But that brought a different problem. The lunar module could only filter the air for 50 hours, not enough for the 3-day trip back to Earth. Engineers had to find a way for astronauts to build an air filter system that could filter the air long enough for the astronauts to get back to Earth safely. To solve this, the engineers made a list of everything available on board. As there was no way to bring parts to the astronauts, they had to find a way the astronauts could build an air filter using only the materials on board. They brainstormed ways these materials could be repurposed. They quickly dismissed all ideas that required skills the astronauts did not have, as there was no time to train the astronauts. Next, they chose some promising ideas for a device astronauts could build to filter the air and made a few prototypes or models of that device. The prototypes were tested on Earth to ensure they worked the way engineers expected them to work. Once tested, the procedure to make the new device was radioed to the astronauts, who assembled it in space. Luckily, it worked, and the air quality in the lunar module improved quickly. There were many more problems to solve before the astronauts could land safely back on Earth. Engineers worked around the clock as they knew time was critical and oxygen, fuel, and water was running out. At the end, their work paid off. On April 17th, the Apollo 13 crew landed safely back on Earth. Engineers had designed an extraordinary set of tools and procedures to create a safe return. Listening to this remarkable recovery, did you hear some clues in the way these engineers successfully approached the problem? What did the engineers do that helped them solve the problem? With a partner, read the text recounting this remarkable recovery on your worksheet and underline the actions the engineers took that helped them solve the problem efficiently. Click the right arrow when you are done. Did you notice how engineers quickly identified the constraints or limits of their problem? They knew they had limited time to come up with a solution. They also took stock of what they had in the spaceship and the skills the astronauts had. Maybe you noticed they brainstormed solutions and quickly dismissed ideas that would not be possible, like ones where they would need to train the crew. Maybe you noticed they built and tested prototypes or models. These steps are all part of the engineering design process, a series of steps engineers follow to find solutions to problems. Most engineering problems are not as complex as the Apollo 13 recovery task, But engineers still use the engineering design process to successfully come up with a solution to their problems. It is a systematic, step-by-step approach that allows engineers to find solutions or to design new products very quickly and with minimal wasted resources. Today, you will be the engineer using the engineering design process to design a paper airplane that can deliver messages to campers. Before you start your challenge, let's look at how the engineering design process was used in our Apollo 13 example. The first step of the engineering design process is to define the problem you need to solve. A good way to define a problem is to answer the following 3 questions. What is the problem? Who has the problem? And why is the problem important to solve? How would you answer these questions for the Apollo 13 example? Take a few seconds to think about it. In the Apollo case, the astronauts had a problem. They needed to get back to Earth safely. Many things needed to happen to solve this complex problem. One of them was keeping the air quality in the lunar module good. We will focus on this smaller problem in our examples. Once the problem is defined, we can move on to step 2, doing background research. In this step, we want to find out as much as possible about our problem and learn from the experiences of others. The engineers in the Apollo case probably did not find similar cases described in the literature, but they probably looked up information on what was on board, how it functioned, and how it could be used in different ways. The next step is to specify the requirements for our solution. We need to write down what is needed to make our solution acceptable and what restrictions we face. Engineers call these the design criteria and the constraints. This step is also referred to as specifying the requirements. Design criteria might include specific physical features such as weight or size, or specific functions such as being reusable, how much it can cost, and so forth. Requirements also include constraints like what materials are available, the environmental impact that is acceptable for our solution, how much time we have to work on the solution, and many more. Some of these criteria and constraints existed in the Apollo 13 recovery case. Can you think of some constraints engineers faced when designing a solution that would bring the astronauts in the Apollo 13 safely back to Earth? You have 1 minute to discuss your ideas with a partner. I will let you know when the time is up. Time is up. In the Apollo recovery situation, the engineers made a list of what was in the spaceship. This was their materials constraint. They also calculated how much time they had available before the oxygen ran out. This was their time constraint. You might have listed other constraints, but did you notice how specifying requirements and constraints helped the engineers focus on realistic options? If they had not made the list of materials available, maybe they would have wasted time creating a solution that needed glue while there was no glue on the spacecraft. Or if they did not know how little time was available, maybe they would not have worked around the clock to find a solution. Specifying the requirements and constraints before designing a solution helps engineers stay focused and efficient. Step 4 of the engineering design process is brainstorming and evaluating possible solutions for the problem. At this point, engineers want to come up with as many ideas as possible, even wild and crazy ones. During this step, engineers often make many sketches of possible designs. Sometimes it is obvious which idea to try first. Other times, it makes sense to combine several ideas to make an even better design. Once an idea or a combination of ideas has been selected, it is time to start developing and prototyping the chosen design. Making a prototype means making a working model of the idea. In the Apollo 13 case, engineers made a prototype or a model of the filter device they designed on Earth before they radioed the design instructions to the astronauts. In this case, they used the same materials as the materials available on the spaceship. A prototype, however, doesn't have to be made in the same size and materials as the final product. It can also be a smaller version and made out of other materials. Why do you think engineers make prototypes? For example, in the Apollo 13 case, why would they use time and resources to make a version of the design on Earth? You have 2 minutes to discuss your ideas with a partner. I will let you know when the time is up. Time is up. Did you think of some reasons? The engineers working on the Apollo recovery must have been eager to send their filtration idea to the astronauts to see if it worked in space. So why did they make a prototype? Although it might seem like making a prototype is a waste of time and resources, it is not. You will see why in the next step. The next step in the engineering design process is where engineers test the design they chose, and that is why they need the prototype. Engineers use the prototypes for all of their testing. Only when the prototype passes all criteria, it is called a solution. Before it is tested, the idea is a prototype, a possible solution. Testing allows the engineers to find out if the idea works and how well the prototype meets all of the design criteria. In the Apollo 13 recovery, engineers tested the prototypes on Earth in situations that mimicked the situation in space. Only when the prototype met all criteria was it seen as a solution and radioed to the astronauts to be built. This procedure made sure that in the spaceship, time and materials were reserved for ideas that had proven to work. Testing almost always involves collecting data about the product's or design's performance. Sometimes, test data will show that the solution does not meet all of the criteria yet. That is okay. If that happens, the project is not over. Instead, a loop starts that includes making changes to the design or trying a new design or testing a new idea. This process is called iteration. It is common to go through multiple iterations and redesigns before arriving at a final solution that meets all the design criteria. Once the final design or solution has been found, one last step remains in the engineering design process. Engineers communicate the results. This means communicating all the findings and design solutions so that anybody who needs to solve a similar problem can use them. Now that you know the steps of the engineering design process, let's try it out on a problem that you can solve: designing a paper airplane that can deliver messages to campers.